Hello everybody, and welcome to this week's SV Lynx video. As you can see, we've given up on sailing and building a boat and moved to Boulder, Colorado.
That is not true. It's just been raining all week here and snowing in the mountains, so that's why we haven't been able to work on the build site.
That's true, which is why we're not going to be doing the build site video this week. But, excuse all the car noise, but we're out in front of our house actually. And these mountains are the San Bernardino Mountains. That's Mount Baldy up behind us. Anyway, so instead of that, we're going to do a video about our fuel polishing system on SV Lynx and the design that we did this week since it was raining all week. I know it doesn't look like it right now, but it was. And so all week we were in doing design work on our fuel polishing system and just the whole fuel system on how that works. So let's go into the office and we'll show you how that is all set up and how it works and why we're doing it that way. All right, okay. Off we go. Okay, so let's go over the design we made for the fuel polishing system. It's hard to believe that something can live in diesel fuel, but it's true. It's called a diesel bug. When your diesel fuel gets contaminated, it's not really a creature, so to speak. It really means that you have runaway bacteria or fungi living in your fuel. These microbes thrive when you get water mixed into the fuel in your tank. Water can get in there from some dirty diesel fuel you purchased, or from condensation in the tank, or even a leaky tank or valve. Microorganisms live and proliferate in the barrier between any water in your tank and the diesel fuel. They then feed off the diesel fuel. Since water is heavier than diesel fuel, it collects in the bottom of the tank where there is less agitation, making a more stable environment for the bacteria and fungi to exist in a relatively nice condition, for microbes anyway.
If these microbes are not dealt with before they proliferate too far, they'll gum up the filters, clog injectors, etc., and corrode your fuel system. Obviously, this is something to avoid. Since SV Lynx will be a hybrid electric and diesel boat, we won't be using diesel as often as a purely diesel boat. That means we may have diesel sitting around in our tanks for longer periods before it's used. Therefore, we need to be even more vigilant in keeping our diesel free of microbes, and that means keeping water out of our tanks.
Most experts will tell you that diesel fuel will last between 6 and 12 months before you run into issues with diesel bug. But that isn't always true. Sometimes you get bad fuel to begin with, and it already has a head start on the infestation. Regardless of how long you have your fuel, you should take precautions to stop microbes from proliferating.
The first step is to keep contaminants and water out of your tanks to begin with. This means, if possible, you should start by filtering diesel as you put it into your tanks to separate out water and any debris. You should do this because you never know what's in the diesel you're purchasing. The diesel could have dirt, dust, rust, scale, bugs, living bacteria, and fungi, or their dead remains in the fuel.
So, before you put all that into your tank, you should put new fuel through a filter as you pour it into your tanks. One famous one is the Baja filter, but that originally cost something like $200. Fortunately, West Marine sells a Teflon-based filter that did an even better in the practical sailor test, and it cost less. Way less, about $10. We'll put a link down in the description below to that.
Keep an eye on that filter as you pour in new diesel. If you see any serious sludge starting to show up in the filter, if possible, stop fueling and go buy your diesel somewhere else.
If you see a few small bits, that's fine and fairly typical.
Okay, so now that you've filtered your diesel fuel on the way into your tanks, you're good to go, right?
Not so fast. Just because you filtered the fuel doesn't mean you got rid of all those little buggers living in the fuel. And those microbes can proliferate at a prodigious rate. So Your next line of defense is to kill them off before they proliferate. If you wait too long and they become rampant in your fuel tank, even killing them with a biocide made for diesel fuel will still clog up your filters with their dead remains.
Therefore, soon after adding new fuel, you should run your fuel through a diesel bug-killing filter, if you have one, or add a diesel biocide each time you put new fuel into your tank to make sure any microbes are dead long before they have any breeding orgy.
The issue with some biocides is that they can be hazardous to your health, or even environmentally damaging. And some diesel bugs develop immunities over time, so you might have to switch out to other chemistries. Also, the initial treatment doesn't last forever. For SV Lynx, since we may have unused fuel in our tanks for long periods, we would have to periodically retreat it with biocide. These biocides do work, and they are far less expensive than using a diesel bug filter. But using a diesel bug filter means less time and hassle adding them to your fuel and periodic maintenance. Plus, you'll have to carry that biocide on your boat.
For SV Lynx, we're seriously thinking about the purchase of a diesel bug filter. The one we're considering runs around $450. That unit processes about 130 gallons or 500 liters per hour, which is a faster rate than our other filters, so that's plenty.
Alternatively, you could purchase a bottle of diesel biocide for about $35, which will last about 1,900 gallons. So it would take a very long time to make up the difference in cost. You'd have to burn about 24,000 gallons of diesel before you made up the difference in price between the filter and the biocide. However, some things are worth money just to avoid hassle and dangers. Not having to deal with a poison on board and putting it into the fuel tanks periodically is worth a few $100s to us. We'll put a link to the description below to the diesel bug filter we're considering.
All right, so you ran your fuel through a filter system as you put it into your tank, and now you killed off any microbes in that fuel. You still can't be positive there isn't some contaminant in the fuel, so you should still clean the fuel before it reaches your engine.
For that, you need a good cascade filtration system and a way to polish your fuel. Polishing refers to running your fuel through a filtration system to get rid of water and other particle contaminants before you send it back to your tank. Doing this fairly often will keep your fuel clean and keep any microbes from getting started and making a sludge in the bottom of your fuel tank. Let's go over the goals of our fuel delivery and polishing system for SV Lynx. Number 1, it needs to filter any fuel that is being delivered to the engine. Number 2, in case any filter is clogged, we need a quick way to get fuel to the engine in case of an emergency where we don't have time to clean out filters. Number 3, our filters should be in an easy-to-access location for maintenance, where spilled diesel fuel won't smell in any living space. Number 4, we want a fuel polishing system to keep our fuel clean. And number 5, we want a fuel transfer system to move fuel from one tank to another. Here you can see the cascade filter system we designed for delivering fuel to our nanny 80 horsepower diesel. We're locating the cascade filter system in this compartment. Reach from a hatch in front of the port sugar scoop stabs. This compartment is just on the other side of a bulkhead from where the diesel engine is located in the port's stern cabin. Since the engine is located under the bunk, we don't want to be dealing with cleaning fuel filters in that cabin, where we might make a stinky mess. So, by locating this in a compartment, we have easy access to work on the filters and any spills won't stink up a living space. It also means we won't have to lift the bed to work on the filter system. It's out and ready to be serviced in an easy-to-access compartment. Here, we've colored the lines in pink to show the fuel flow path. The white filter here is the diesel bug filter, which is what the fuel reaches first. This filter uses magnets to disrupt the cells of the microbes and kill them. The second filter is our fuel deputy. This separates water and particles without the need of a paper filter. The fuel enters baffles, which create a swirling action to separate water and solid contaminants from the fuel. They sink to the bottom and may be drained off and disposed of safely. There's a monitor sensor, which will set off a warning light at the helm and nav station when this needs to be drained. We like this model because it will take out 98% of water and 95% of solid contaminants before they reach a paper filter that needs to be periodically changed, thereby prolonging the life of those filters. The third filter is a 10 micron Raycor 900. This is a paper filter and also separates water, assuming any makes it through the fuel deputy. From there, the fuel goes to the nanny diesel, which has its own 2 micron filter. But if the previous filters have done their job, very little will get through. When we want to polish our fuel, we just throw this one T-valve and we divert the fuel to this second Raycor 900. Neither of the first two units use paper filters, and they're used for both the primary and fuel polishing systems. However, we wanted a second Raycor 900 for the fuel polishing. This serves two purposes. The first is that while polishing the fuel, we are only dirtying up the secondary Raycor filter. If, for any reason, we need to get underway with the diesel engine, we can just switch back to the primary Raycor and we'll be ready to go. Likewise, if we try to start the engine and it's having trouble due to the primary Raycor being clogged, we just throw these two valves and use the fuel polishing Raycor to send clean fuel to the engine until we have time to service the primary Raycor filter. If either the debug or fuel deputy filters are the culprit, we can also use this valve to bypass them, still using one of the two Raycors as filters while we get underway. We can then service the other filters before putting them back into the cascade. Now, let's talk about transferring fuel between tanks. Our diesel tanks are located in the forward lockers, so we only want to run two lines from there to the engine, one for bringing fuel and the other as a return line. While burning or polishing fuel, we have the choice of which tank is being used via an electric valve, which is located near the two diesel tanks. Also up near the fuel tanks, we have a second electric valve to choose which is the return tank. Both of these valves can be activated from the helm station. The first one switches which tanks are sending fuel, and the second valve diverts the return to either tank. That means we can send fuel from one tank to the other through the polishing system. That way we transfer fuel and polish it at the same time. Of course, these electric valves will also allow us to send fuel from either tank to the diesel engine. So, that is our fuel delivery and fuel polishing system on SV Lynx. Normal fuel operations can be done by switches at the helm station. When we want to service the filters, or use the polishing system, we enter the port stern compartment and do our work. Now, on the subject of fuel, we made a video around Christmas of 2022 about fuel tanks, and we decided to go with epoxy tanks during that video. Since then, we've had trouble finding such tanks for sale. We considered going with polyethylene tanks, but have decided to go ahead and construct the epoxy tanks ourselves. We'll build them right into the boat. This is how Schionning Designs originally suggested that we construct the boat, so it isn't something we're doing out of left field.
We'll use Vitas ports for the fuel tanks and build them all to CE standards with all the proper bells and whistles. In the end, we decided to go with this route because of the weight and cost savings. Plus, we really want epoxy tanks, and this way we get our first choice in fuel tank material.
You'll get to see the entire process of us building these fuel tanks in future videos, and you'll see us build our fuel filter and polishing cascade system as well. This was just the design of the system. In fact, at this point, if anyone out there has any suggestions, it would be great to hear from any of you. The build comes later, probably in 2024, since we will be busy building the shell of SV Lynx during 2023. However, the fuel tank will likely get shot this year, but we'll see how far we get.
I'm going to get back to work on some boat planning while Phil takes a few questions from viewers of our previous videos.
Sounds good. See you soon. All right, let's take a few questions from the last couple of videos. We'll start with last week's video about my big mistake. Tom Mussington asked, did you consider a hookah type system for supplied air so you could use it on the boat after you were done assembling for hull cleaning? Well, the answer is yes, we did consider a hookah style unit, but the fact is that we have a full dive compressor on board and all the scuba gear tanks and everything, so adding yet another air supply system to the boat would just add more weight when we can always use our scuba gear if we want to clean the bottom of the boat. So no, we didn't consider a hookah style unit, and for our air supply on the making of the boat, those respirators that we use could also be hooked up to a external hose if we don't want to use a filter to bring in clear air. It'll be a little more hassle because you have to deal with a hose, but on the other hand, we don't have to pay for and replace filters. So that's a possibility. Thomas Wild asked, would it be possible to connect two of your 48-volt batteries in series to make 96-volt? Or are they too big and heavy to carry two on the dinghy? The problem is we're not actually using 48-volt batteries. Our batteries that we have for the prototypes are 24-volt, and we're using two of them and putting them in series to get to 48 volts. And so there's no way to go to 96 without adding two more of those. And that would be impossible. That's 400 pounds of batteries, and it would just take up way too much space inside the small rib. So we really can't go with that. DC asked, how fast does the tender go using 185 amps? Since it wants 96 volts, you should build one with 100 amp cells. It would perform way better. Well, the fact is we built it with 230 amp cells, so that isn't the problem. The outboard itself is only pulling 58 amps, even though we can supply as much as it wants. The maximum it wants is 185, and we did set our BMS so that it wouldn't overdraw, but on the end, when we tested it, it only pulled 58 amps. So we have no idea of why that's true. Perhaps when it was under more of a load, it would pull more amps, but that doesn't matter because as it was, we couldn't get out of the hole shot with it. So it's just not going to work. Let's see, Rusty asked, when building your own boat, it will take twice as long as expected and cost twice as much if you're lucky. If not, it will take 4 times as long and cost 4 times as much. We get that a lot from various people, and Rusty's not wrong. But nobody really knows how long it will take us to build this boat because no one's ever built a Solitaire 1520, and we helped design it, and it's the very first one. But Schionning estimated 6,000 hours to build it, and we added 40% more on top of that. So we estimate for our build 10,000 hours, so that's 4,000 hours more than their estimate. So we're not far off of his 50% longer comment. Now, as far as 50% more expensive, or twice as expensive, that is very unlikely. And the reason I say that is that this isn't an unknown anymore. If we were only in the planning stages, that would be fine to guess that our estimates would be wrong, but we're not in estimates anymore. We paid for everything. We bought the boat. We bought all the systems for the boat. So basically, all the major costs have already been paid. The only thing left is how much sandpaper we use or that kind of thing. And we've built in a huge amount of money for that kind of small overrun. We have thousands of dollars for just sandpaper that we've set aside. Not that we think it'll be that much, but we've already set aside way more than we need for those small little things like that. So it's not going to have a major overrun in cost simply because we already paid it. So we know what the cost was. Leon says, I was wondering if you have enough storage for all the different wet, bad, foul weather garments that has been planned and you've planned into the design. So have we planned for where we're going to put all our wet weather gear is what he's sort of asking there. And yes, we have. There are 2 large compartments near the stern of the boat, one on each side, just above the sugar scoops with a hatch that goes down from there. And in one of those, we're going to have our dive compressor, but it will also be wet storage for things like wetsuits and foul weather gear. So that all goes down in that deck. There will be a hang bar there that we can put them from and hang them down into that. Now, it doesn't have stand-up height, but we don't need that for hanging these types of things. So it's plenty big for that. I'll show you what it looks like right here. And Bunyip Dan asked, your door raid solution looks quite interesting. Hopefully you will be designing a method of sealing, locking them down for really rough weather. All right, so other way of sealing them and locking them down. Yes, from the inside, there's a insert that goes inside and actually with an O-ring seal closes off the opening from the outside so that no water can get in if it's really, really rough out. And if it's that rough, we just close them up. And that should be easy enough because it's from the inside. You don't have to go out on deck or anything, and they just push in. And so that's easy. John Anderson asked, I wouldn't go with door raid scoops. The ventilation you gain is not worth the risk of getting them overwhelmed by a big wave or torn from the hull from such a wave. We almost never open our deck hatches for cabin ventilation, an opening port light on the inside of the forward cabins brings in huge amounts of air as the wind tries to squeeze under the bridge deck, which then flows out the open port light in the aft cabin. Even with that airflow available, we're much more likely to turn on our 12-volt air conditioner or cabin because of the low humidity it provides, and it can't be beat for a good night's sleep. Oh, there's a lot there. So let's start with the dory boxes getting torn off. These are very low profile, and here I'll show you where they're located. They're up on an angled part of the deck, not down on the side of the deck. So the amount of times that a green water wave is going to wash along that part of the boat is almost zero. In fact, if we go that far into a wave, if we bury the bows that deep, we're in have much bigger problems than those dory boxes. Most of the time that they're not going to be taking that kind of wave. They're also low profile. We're going to have backing plates on them, so I doubt they're going to get torn off, even if a green water wave hit them. Now, as far as putting a port light on the inside of the hull, as you can see in this version of our cutaway from the 3D on it, you can see that there are camphor panels on the inside of our hulls there. And so there's not really a place to put a port light on the inside of the hulls on our particular boat. Those would be facing down and it'd be constantly hit by waves as the boat does go down in that position. So we can't put a port light there. However, we do have port lights on the outside of the boat, and those will bring in some air, but we just think that we might need a little bit more. However, just so you know, we're not going to be putting those dory boxes on as we build the boat. We're going to build it with the port lights only, and the hatches, of course. And then we're going to go out sail it, and we're going to see what kind of ventilation we get from it. And if we feel that it needs more, then we'll cut in those dory boxes and add them. But if we find that it's already fine and we're happy with the ventilation, then we don't need those. So that's something we'll decide in the future. And finally, he mentioned using your AC because of the low humidity and such. And we are putting AC in all the cabins of the boat, one in each one. And so therefore, yes, in any really hot places, when we're not underway, we can use the AC if it's just sweltering out and there's no wind or any of those kinds of situations. So it's available when we want to use it. All right, well, that'll do it for this week's questions. And so let's just get to the wrap up of the video. All right, well, that's this week's video, and we hope you enjoyed all the stuff on the fuel and the fuel polishing system. So we'll get to that lot now because it's sunny, and so we'll be out there putting up the solar panel system and showing you all of that hopefully next week. So we'll see you all then.
And don't forget to like and subscribe and ring the bell icon to learn about our next video.
You bet. And thank you to all of our patrons, as always. Here they are around us. And we really appreciate their support. And all of you who watch our videos. So thank you, and we'll see you next week.
Bye.